Students, in the previous slide, we had seen the formula along with its name, along with the oxidation state. In this question that I have for you, which pair of oxyacid of phosphorus contains pH bond? To work this numerical, you need to technically know how to write the structures. So how do I write the structures? Though I am teaching an unconventional way of learning it, remember my code word to write the structure. P double bond oxygen, umbrella is my code word. P double bond oxygen, umbrella is my code word. Let us try for the first option that I have, H3PO4. When I devise this H3PO4, phosphorus, the central atom is phosphorus, double bond O, as I said, code worded as umbrella, 3 bonds like this. Total number of oxygen atom that I have is 4. I have used up 1, remaining 3. Allocate the remaining 3 to 3 bonds and left over with 3 hydrogen atom, H, H and H. From this I understand from the structure that I do not have any pH bond at all. Therefore, option A is not the relevant answer. I'll continue helping you again how to devise the answer for it. Taking the next step, H3PO3. Help me out as I do. So you are aware, phosphorus, double bond O, 3 bonds. Now total number of oxygen that I have is 3, used up is 1, remaining 2, I give 1, 2, 3 hydrogen atoms are there. I devise it, H, H and H. Yes, I have one pH bond. But you look into this option A, one satisfies, the other doesn't satisfy. If I look into this, I don't have H3PO3. I look into option C where I have H3PO3 which is satisfying. I also have H3PO2. Try working out for H3PO2. See if it satisfies this question. Therefore, I have H3PO2. I will take phosphorus, double bond oxygen. Umbrella is my code word. Total number of oxygen that I have is 2. Used up 1, remaining 1, therefore I have 1 here. 3 hydrogen, 1, 2 and 3. Now I read the question, which pair of oxyacids of phosphorus contain pH bond? I suppose my relevant and most probable answer is H3PO3 and H3PO2 because both of them have got pH bond. You may have a doubt again. Why don't you try out for H3PO2? Because it has got an option called H3PO2 also has. I have this HPO3, I would like to speak about this. HPO3 is metaphosphoric acid. Metaphosphoric acid. It doesn't have an open chain structure as I have here. It has got cyclic structure, cyclotrimetphosphoric acid, and there it doesn't have a pH bond. So do remember, HPO3 doesn't have an open chain structure as I have written here. It has got a cyclic structure. Cyclotrimetphosphoric acid is the structure that I have to write, that is HPO3 and then thrice. Hope you have understood this question. In this question, we have in pyrophosphoric acid, you are lucky enough to have the formula also H4P2O7, the number of sigma and pi bonds present in the structure. So how do I work this? So you are aware, when I try to write the structure, I remember telling one code word, P double bond O umbrella. So let me devise that formula once again. Therefore, P, there are 2 phosphor atom P, taken care, double bond oxygen, umbrella 1, 2, 3, 1, 2, 3, taken care. Total number of oxygen that I have is 7, used up is 2, remaining is 5. Now how do I allocate this 5? I can give 2 here and 1 here, happy, 2 here and 1 here, very happy. But who's going to take 2 and who's going to take 1? Whenever this problem arises, distribute the odd one to the center. Therefore, you have one oxygen at the center. Taken care. Remaining that I have is 4. So these 4 are allocated to 1, 2, 3 and then 4. The remaining 4 hydrogen atom that I give 1, 2, 3 and then 4. This is the structure of pyrophosphoric acid. Hope you have understood how to write the structure. When I look into the structure again, the question clearly says calculate the number of sigma bonds and pi bonds present in it. So let me calculate the number of sigma bonds and pi bonds present in it. Now, how do I do it? I break the bond now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Don't be happy with this. You have got 10 sigma bonds. A sigma bond will also be accompanied by a pi bond. 10, 11, 12. Total number of sigma bond that I have is 12. Hope you have understood. Wherever there is a double bond, it should necessarily have a pi bond. There are 2 double bonds. Understood that there are 2 pi bonds present in it. Therefore, the relevant, most appropriate, the correct answer for this is option D, 12 and 2. Hope you have understood this. Students, in the previous question, when I had explained to you about metaphosphoric acid, I said that you cannot write the structure, open structure for it. Now I have a formula here, HPO3, written in cyclic format. It is cyclotrimetaphosphoric acid. Previous question we calculated the number of sigma bonds and pi bonds. Now I want to calculate the number of single bonds and double bonds that this cyclotrimetaphosphoric acid hosts. And also, I would also calculate the number of POP bonds. Together we shall try to solve these 2 questions. How do I write the structure of it? Cyclotrimetaphosphoric acid, HPO3, it is cyclotri, I have written it 3 times. From this I understand phosphorus is 3 times arranged in cyclic fashion. Therefore, P, P and one more P. Put it up like this. Remember my technical terms that I had devised to you earlier, that whenever I have phosphorus and I want to write the structure, double bond O and umbrella, telling that phosphorus is surrounded by 5 bonds. Therefore, here double bond O, umbrella 1, 2 and 3. Again, double bond oxygen 1, 2 and 3. Again, double bond oxygen, and I'm writing 1, 2 and 3. Total number of oxygen atom that I have, 3 into 3 is 9. I've already used up 3. The remaining 6, 1, 2, 3, 4, 5, 6. Hope you have understood. Number of hydrogen atom that is remaining is 3. That will definitely be for OH, OH and OH. If I happen to look into these 2 questions, let me complete the later on question here. The number of POP bonds in cyclotrimetaphosphoric acid, POP bond is specifying, therefore I have 1, 2 and 3. The number of POP bonds is 3. My option is option C, which has got 3 POP bonds. Hope you have understood this. Coming back to the next question. In cyclotrimetaphosphoric acid, the number of single and double bonds that are present in it. I'll have to devise it again. Therefore, let me count again. It is 1, 2, 3, 4, 5, 6, 7, 8, 9. Hope you have understood. But there's another link, as I said, that is 10, 11, 12, because there is a bond that is existing between oxygen and hydrogen. Therefore, total number of single bonds that I have in this is 12. Total number of double bond that I have is 1, 2 and 3. Therefore, there are 3 double bonds and 12 single bonds. Hope you have understood. Therefore, the correct answer is option C, 3 double bonds and 12 single bond. That is, option C is my right answer. Dear student, in the previous question, we wanted to calculate the oxidation state of the central atom. Example, ammonia. In ammonia, nitrogen is the central atom. If I want to calculate the oxidation state of the central atom, example, ammonia, as I mentioned, I need to know the valence electron that it possesses. Nitrogen, forget, for example, I do not know what is the atomic number. I need to know which group it belongs to. Nitrogen belongs to group 15. Therefore, valence electrons in this is 5. Therefore, I write 5 plus I add the number of monovalent atoms that are linked to it. Hydrogen is a monovalent atom. The number of monovalent atoms that I have is 3. Therefore, I add 3 and divide the entire concept by 2. Therefore, 8 divided by 2, I get the answer as 4. I don't have the hybridized state. Students, I want you to learn this concept. If you know to get this number, you can easily predict what is the hybridized state. For example, if the number is 2, the hybridization state is sp. If the number is 4, the hybridized state is sp3. If the number is 5, the hybridized state for this is sp3d. If the number is 6, hybridized state of this would be sp3d2, and finally if it is 7, sp3d3. By all probability, I got the answer as 4. It is sp3 hybridization. It is for ammonia in the previous question. Coming back again, what is the hybridized state of phosphorus in PCl5? If it is PCl5, again I am reminding you, the central atom here is phosphorus. Phosphorus belongs to group 15. Group 15 valence electrons are 5. Chlorine is a monovalent atom. 5 chlorine atoms are there. 5 plus 5, 10. 10 divided by 2 is 5. Therefore, my correct option would be sp3d. Therefore, this is my correct option, option A. To train you all with one more question, think about it as I am talking to you. If I give you iodine heptafluoride, just like that I am trying my students, just try it out. Iodine heptafluoride. I do not know what is the atomic number of iodine. Excellent. I all need to know is which group it belongs to. It belongs to group 17. Iodine belongs to group 17. 7 valence electron. Fluorine is a monovalent atom. 7 plus 7, 14. 14 divided by 2 again is 7. Therefore, my answer would be sp3d3. Hope you got it. Therefore, never make a mistake in calculating hybridization state. Dear students, in this question, the sulfate and a metal has the formula M2SO4 thrice. What would be the formula of its phosphate? This is one of the basics in chemistry. You should be knowing this. To formulate the answer for this, let us try deriving from the question that is being put forth. We have it as M2SO4 thrice. I understand that it is written in the form of M plus 3 SO4 2 minus. Arguably, you can understand that my metal is 3 plus, sulfate is 2 minus. He clearly specifies in the question what would be the formula of its phosphate. I understand that my metal would still remain as M3 plus. Phosphate, I remember the formula of phosphate, PO4 3 minus. According to the basics in chemistry, you should be understanding that plus 3 plus plus 3 and 3 minus get cancelled. Therefore, it is MPO4. Therefore, the correct and the right option is option D, MPO4. Hope you have understood. Let me try illustrating it once again. If I happen to change the combination, what would be the formula of its sulfide? That means I am trying to work in the fashion of M3 plus. Sulfide happens to be S2 minus. Then the necessary answer is M2S3. Hope you have got it according to the crisscross methodology. Let me try for another basic and the most important in P block is to analyze the magnetic character and property of various oxides of nitrogen. To remember the code word to apply for these type of question, I would like to give this code word. Nitrogen belongs to group 15. Number of valence electrons, 5. Oxygen belongs to group 16. Number of valence electrons is 6. So wherever I find nitrogen, I write it as plus 5. Wherever I find it as oxygen, I write it as plus 6. I am talking in terms of valence electrons. Let me try adapting this. Which of the following oxides of nitrogen is paramagnetic in nature? I understand paramagnetic, presence of an unpaired electron. Diamagnetic does not contain an unpaired electron. By all probability, if I try to find the magnetic character of this, according to the logic that I have said, nitrogen plus 5, oxygen it is plus 6. Let me try it out. Nitrogen plus 5, I remember telling 5 into 2, 10, 10 plus 6 happens to be 16. Good. Calculate the total number of valence electron. Come back again. N2O5. 5 into 2, 10. 6 into 5, 30. 10 plus 30 happens to be 40. Fine. Very good. NO2. Nitrogen dioxide. Nitrogen 5. Oxygen 6 into 2 happens to be 12. 12 plus 5 is 17. Option D. Nitrogen 5 into 2, 10. Oxygen 6 into 3, 18. 18 plus 10 happens to be 28. If you happen to look into all the answers in this particular question, you have a mixture of odd and even. Remember the code word? Paramagnetic, presence of an unpaired electron. It should certainly be an odd number. Odd number in this is 17, that is NO2. Therefore, the correct and the right answer is NO2. To summarize it, you have to calculate the total number of valence electron. Nitrogen belongs to group 5. Oxygen belongs to group 6. Add up together. If you get an odd number, paramagnetic in nature. If you get an even number, diamagnetic in nature. We shall work few more to get a gist of this problem. The next question, which of the following is an anhydride of nitric acid? These compounds should be dealt such a way that whenever you are studying any compound, try to learn the preparation, properties, uses. This will definitely help you in CET. Now in nitric acid, if I happen to remember, which of the following is an anhydride of nitric acid? I mentioned that you should be learning the properties clearly. Let's try to understand this. My nitric acid, which is HNO3, the basic in nitric acid. Nitric acid, difference of one oxygen atom in this will lead to HNO2, which is nitrous acid. Reading it once again. Nitric acid, difference of one oxygen atom, nitrous acid. Same logic applied for phosphoric acid, difference of one oxygen atom, phosphorus acid. Now my question, which of the following is an anhydride of nitric acid? I'll try to write this. My nitric acid HNO3. I'll try to rewrite this formula once again as NO2OH, one and the same, HNO3. I'll remove water molecule from here. I get what is known as N2O5. Therefore, the correct and the right option is N2O5 is the right answer. Let me attempt one more.